Hello everyone, I am Jay Krishnan from Artificial Intelligence and Data Science Department. Now I am going to talk about my final year project titled as StrongBones Cracking the Silent Disease. It is nothing but osteoporosis detection using deep learning. Osteoporosis is a bone disorder in which bone density reduces, making bone weak and prone to fractures. The major challenge with osteoporosis is that it is a silent disease, meaning symptoms appear only after serious damage occurs. The traditional medical diagnosis methods such as DEXA scans are costly and require specialized equipment and are not easily accessible everywhere. To address this issue, my project focuses on building an automated deep learning based system that can classify bone medical images into normal, osteopenia, and osteoporosis. This helps in early detection, reduce dependency on manual diagnosis, and improve clinical decision support. And the objective of my project is to detect osteoporosis using medical images to apply deep learning convolutional neural network model for classification, to compare multiple models and select the best performing one, to provide an automated and accurate prediction system. And the system requires and the system requirements include softwares like Python, TensorFlow, Keras, NumPy, Matplotlib, and Gradio, and it requires system with a minimum 8 GB RAM and a GPU supported system. These tools enable efficient training, evaluation, and deployment of the deep learning model. The dataset used in the project consists of medical bone images organized in a folder-based structure. Each folder represents a class. This structure allows TensorFlow to automatically generate labels. The dataset is divided into training set, validation set, and testing set. This ensures proper training and unbiased evaluation. In the dataset loading, it includes read images from directory and resize images automatically, and assign labels based on the folder names, and loads the data in batches for efficiency using image size equal to 224 and batch size declared as 32 and and declare shuffle equal to true. In data preprocessing is essential to improve model performance in that image resizing includes images are resized to 224 cross 224 so that they can uniformly processed by CNN model. The pixel values are scaled from 0 to 225 to 0 to 1, which speeds up training and improves convergence. CNN requires channel conversion so that it converted into RGB format to ensure compatibility with CNN architecture. Whether if a dataset requires a data augmentation, it helps in prevent overfitting, improve generalization, and increase dataset diversity. The next step is to split the dataset into train, validation, and splitting testing data. Using TensorFlow's TF.data pipeline, the dataset is split into training data with 70%, testing data with 15%, and validation data with 15%. This ensures fair performance evaluation on unseen data. In model implementation, I implemented and compared multiple deep learning model includes custom CNN, and the architecture includes convolutional layer for feature extraction, max pooling layer to reduce spatial size, and I use flattened layer and dense layer, and softmax function as the output layer activation function. The reason for this architecture used is it is simple, fast, and act as a baseline model, and I use mobile network which uses transfer learning pre-trained on ImageNet and lightweight efficient, and it provides high accuracy with fewer parameters. In third, I use residual network. Deep residual network solve vanishing gradient problems and extract complex features and performs well on complex medical images. In model compilation, I use model.compile function. In that, Adam as the optimizer, loss function as categorical cross entropy, and I use accuracy as the matrix. In training process, I use epochs equal to 8 because it is enough for convergence and it prevents overfitting and balanced training time. Training and validation accuracy and loss were monitored for performance analysis. In that, I use matplotlib library to plot a graph between model accuracy like train accuracy versus validation accuracy, and I also develop a graph for model loss, simply train loss versus validation loss, and I also print the training accuracy and validation accuracy, and at the end of the model building I print the classification report and confusion matrix for all the model. It is the same for all the 5 models I used. It is residual network. In residual network, I use dense and global average pooling 2D and Adam as the optimizer and categorical cross entropy as loss function. I use model.summary function to display the function table, that is model table. And at the last, I fit the model with epochs equal to 10 and validate with the training data and validation data so that it learns the deep structure of the data. That at the end I use random library to pick random images from the data set, and I push the images into the model, and it detect whether a patient had a osteoporosis or not. It also displays the bone image with the probability. It randomly picks the osteopenia image. In that, it shows normal is with a 0 probability, and osteopenia with 100 probability, and osteoporosis with a 0 probability. In addition to that, I install Gradio, which is a Python library which creates a simple user interface so that it detect it also it detect whether a patient had a osteoporosis or not. I also develop a Python code for the Gradio implementation. After I execute this set of code, we have to click this link. In that, the inputs are image name. For example, I give patient name as Kumar, age is 50, gender equal to male, and I have to select an image. After selecting an image, click analyze and generate report. After clicking the analyze and generate report, it shows the patient is detected as osteopenia. It also generates a report with the patient name, age, gender, and date and time, and the diagnostic result, whether the patient is detected as osteopenia or osteoporosis, and it also shows an icon to download the result. Thank you. To conclude this, the project successfully implements a deep learning based osteoporosis detection using multiple CNN model. By comparing performance metrics such as accuracy and loss, the best performing model was selected, and this system demonstrates the practical application of AI in healthcare and enabling early diagnosis, improving patient care and reducing fracture risks. Thank you.